guys, most of you have seen a lot of liquid cooling builds from Linus or J2Zen, and you may be thinking that that's it, that's top of the line, there's nothing else can be built. So well, until now. Today we will show you something that blows your mind, and this thing is sick. Introducing world first dual Xeon rack mount server with a TITAN RTX GPU with the full custom liquid cooling system. This is the craziest and most expensive computer you have never seen. So before we start, let me tell you what brings us to this project. Most people may think that liquid cooling is just for gamers, because we have seen gamers in the past using liquid cooling for their builds, and for sure that looks really good. Now the problem is when you try, and those builds is for 1 or 2 video cards, and that's fine. But what happens when you want to install 4 or even 8 GPUs, like in this case? We also have 4 GPU workstations. You can check them out on the link below. But today's video is about the 8 GPU rack mount server. The main question that people ask is why water cooling is so expensive and why we have to overpay for it. So here we are to answer you that question. There are 3 benefits that liquid cooling brings you. The first one is low noise, the second one is low temperature or low thermals, and the third one is better performance. We have seen the latest RTX from NVIDIA, and they get really hot. They don't dissipate the heat properly, that's why the video card gets more than 86 degrees in normal task. And that's with the normal RTX. The TITAN RTX, this case, is even worse. We have been testing with 2 video cards on the same case, stock fans, and the temperature will be up to 86, even sometimes 89. Just to put it in perspective, we have, for example, the TITAN RTX, which is a video card that has 24 gigs of RAM, and that video card is meant to be for deep learning or video rendering, because you have a lot of memory on the video card, which is help to people for doing big render times, and also for deep learning when you're using big batch files that use the memory on the video card. Now we also have the V100, which is a video card made for servers, and this card have the price of this card is $7,000. If you compare the V100 $7,000 compared with the TITAN RTX, there's a huge difference on price. So the question would be, why should I buy the Tesla V100 instead of the RTX, which I can save some money and the performance is similar? In order to see this in more depth, let's build the server with the Titans and see what happens. I am installing the GPUs, and technically they fit, but there is some problems I'm going to show you. NVIDIA was smart enough to block TITAN RTX from using in multiple GPUs configurations. As you can see here, when you install one Titan next to another, the fans are completely blocked. No clearance between them, and I'm pretty sure the GPU would not be able to dissipate the heat. Let's run the benchmark and see what happened with this configuration. Okay, we're gonna start the benchmark, and this part is really important. So the system that we got here is the RTX, so 4 RTX Titan, right? And the whole system is with the air cooling system, with the fans on the front and then the RTX here. As you can see, the gap between the video card is really small. You don't get any gap between the fans, and we're gonna see how this is gonna perform on benchmarking on deep learning. Fans will be how they come default, and then we're gonna speed up to the maximum to see if we can cool the video card. This is Ubuntu 18.04, everything is installed for running deep learning benchmark. On the left side we got the RTX Titan, 4 of them, and as you can see the temperatures right now is 41 degrees Celsius, because of course the video card is idle. No usage of the memory, GPU usage is 0, and wattage is 11, doing nothing here. Now on the right side we have the benchmark. This benchmark is one of the latest for TensorFlow, latest version, and we're gonna use ResNet 50 1000 iterations unit batch files, and the batch size that we are using is 64. We're gonna start running the benchmark. We're gonna see how the computer is gonna be working. So we're gonna start running. So right now, after 6 minutes and 32 seconds, we can see on the right side that we dropped down all the way down up to 378 image per second, sometimes with peaks of 196. So it's not stable at all, and the performance has just decreased more than 50%. And this is something important. We're losing 50% of this video card, and the temperatures is still 88, 88, and 87, and 3 of the cards. And the performance on the water consumption, we're getting 100, just 100 for this video card. So we're running this, and you have to keep in mind that we have the lid open. Once you close the lid, it will be even worse, because this video card, the airflow, because there are no blower edition, all the air will goes up, not from the back like the blowers edition they have. So right now, the hot air is concentrated right here. If we close the lid, this scenario will be even worse. And it's good to understand that there is no blowers edition for Titan RTX on the market. This is the only video card you can get with the fans from NVIDIA. So this scenario is for 4 GPU. Imagine when you install 8 GPUs, the thing will be even worse. These cards here on the left side, the one that is close to the case, this one and this one here will be crazy hot. What it means, it will automatically show up errors on the deep learning model, or the computer will crash or shut down. Even with the fans on the max, it doesn't matter. The gap between the GPU is too small that it's not enough room to cool the GPU. So people say that with this server and for the Titan RTX, if you speed up the fans of the server up to the maximum, you get better performance. Now we're gonna try that now, and what we're gonna do is in the default mode, as you can see, we're gonna go to the computer with the IPMI. It's a built-in software that Supermicro has on the server. We're gonna put the fan to the maximum, as you can see here, to the full speed, and we're gonna check the performance if it changed or not. Okay. So that this is gonna be really loud right now, so you can put down your volume if you want a little bit. Okay, right now, as you can see here, the temperatures of the video card is still really bad. We got the fans at full speed. We got 86, 88 degrees Celsius. More than 86, this video card will through for sure. And we're gonna see the performance we're getting on the deep learning side. So we can see here, before we start with 900 mAh per second on the water cooling system, and here we're getting 321 mAh per second, which means it's 3 times lower than the water cooling system we had when the temperature was around 50 degrees Celsius. So even as you can see there, even with the fan speed on the max, with the headphones and everything, the noise is crazy noisy. We're talking about 90 decibel. It's almost the same way you feel when you are on the airplane and the working engine is running. They will run at 110, something like that, and it's really noisy. And this is just with one server. Imagine when you have an entire room and you want to install 10 of them or even 5 of them. The crazy noise that will generate inside the server, for me at least, is not an option. Okay, so now we're gonna do is to run the same benchmark for deep learning. So we have the comparison, and this time we're using the BIZON workstation server. It's a complete water cooling build we did in order to see the performance and comparison. We're performing with 4 Titan RTX. We're gonna be doing the same test here. So on the left side, like before, we had the video cards. On top we got the 2080 Ti. This is not important. We're gonna be running the test just on the Titan RTX, 4 of them, to make a real comparison between the both systems. And on the right side, we're gonna be running the same test. ResNet 50 with 64-byte files and 1000 iterations per epoch. So we're gonna check that now, and we're gonna run the test and see how it's gonna perform. Okay, so we have been running the test for 54 minutes right now, and compared with the 6 or 10 minutes before, in order to make sure, in order to show you how this computer keeps stable, temperature is stable, and the noise level the same. So as you can see here on the screen, we got 50 degrees Celsius, 47 and 45 degrees Celsius on the Titan RTX. They're running 100%, and the performance we're getting is the same. We're talking about the 900 mAh per second at this time. 900, 890 something. So average, it will be 900. Noise level, as you can see here, is still the same. And remember that this noise is going from the power supply. So 53, 52 decibels right now. Okay, now we're gonna be running a test for 3D render. I know that most people that buy this machine is for deep learning or 3D design, and we're gonna be running the Luxmark with 4 video cards. We're gonna see how the performance in terms of temperatures and performance. Okay. So as we can see here, we got the 4 GPUs selected, all of them, the Titan RTX. And we're gonna be checking the temperatures and the performance. Right now we see the usage of each GPU is 100%, which is good. Test is running fine. Temperatures right now, as we can see, is 89, 88 degrees Celsius, even 92 degrees Celsius on this one. What means the performance will decrease 3 times because of the consumption of because of the high temperatures on the video cards right now. 94 degrees Celsius, actually it's the first time I see a video card getting so hot. As we can see here, this is something important for 3D and 3D designers that use the server for rendering. Most of the video card will show up an error message, like we're having here. So this video card is not meant to get more than 92, and this error message is showing up. Now what happened? Let's say that your render and the machine is running the whole night, and this error message is showing up, but you cannot check the machine, and there is nothing to stop it. What will happen is that it will damage the video card. Yes, this is the result we got from the video cards with air cooling system. Okay, for our final test, we're doing the benchmark through a Luxmark, and we're gonna be using the 4 Titan RTX we got in this system. So right here, we got we can see the performance of this video card is using the 100% usage. Water consumption is 250 to 235, something like that, average. And the temperature we're getting is 50 degrees Celsius, 52 maximum until now. Okay, the test has finished, and as you can see here, this thing is crazy. We're getting 190,178 score on this bench with just 4, as you can see there, 4 Titan RTX. And the temperature, the maximum we got was 52 degrees Celsius when we were running the test. Now, what we're gonna do now is, since we have this machine with 4 Titan RTX and 4 2080 Ti's, we're gonna be running the same test with all the video cards and see the performance at the end of the test, just for fun, 8 of them. So now you can see there all the cards are getting full power. 2080 Ti's 230, Titan RTX 250. We're gonna be seeing difference between the Celsius between the 2080 Ti compared with the Titan RTX 2. Okay, the test has finished with 4 Titan and 4 2080 Ti's on this server, and as you can see here, 360,438 points on this benchmark. It's double of the performance with 4 Titan RTX. So increasing. So to take some numbers here, the first test we did with the server without the water cooling system with 4 Titan RTX, the performance on the Luxmark was 92,909. With the same 4 Titan, but with the water cooling system, the performance was 190,712. So even twice, the difference on performance just going with water cooling. And using the 2080 Ti's and the Titan combined, and for a total of 8 video cards, we see double the performance with 360,438. Okay, I know you guys, some of you are thinking, we can mine with this thing, and the answer is yes. We have downloaded the miner for Ethereum, and we're gonna see the performance because this computer is crazy. It's more than $50,000 computer with Titan RTX and 2080 Ti. So let's see the performance here. Okay, everything is ready and set up to go. So share accepted, which means is good. Everything is set up in the right way. We're getting 420 megahatches in total, and each video card is providing 55 megahatches. 55 megahatches on the Titan RTX and 50 megahatches on the 2080 Ti's. This is the performance. And on the right side we got the temperatures. This is crazy. As you can see here, the same temperature, 45, 43, and using the full power of the video cards.
So this is the best miner in the world?
So this, yes, for sure, this is the best mining on the world. What it means this for our test, it means that this server, even if you want to set up on the server room, is not gonna work. Why? Because this video card, the RTX Titan, because of the design, there are no Blowers edition, and there is no Blowers editions on the market. They will get very hot, and the only way to keep a little bit cool is to put the fans to the maximum. But as you can see on the test, that doesn't fix the problem. You lose 3 times the performance instead of having the water cooling system we have, which, by the way, is the only solution at this moment for the Titan RTX. Benchmark of BIZON Z9000 liquid-cooled server with 8 Titan are much better than the way we expected. Top-of-the-line GPUs like Titan RTXs are extremely hot and require liquid cooling. Noises level of BIZON liquid cooling system is up to 50% lower versus air cooling, 50 decibels versus 90 decibels. Temperatures are up to 50% lower as well, 50 degrees versus 90 degrees Celsius. Performance is up to 3 times faster. GPUs do not overheat and do not activate thermal throttling. Your investment in liquid cooling system will pay for itself in a few months. It's been an incredible project and BIZON team did a great job. BIZON engineers spent months of research, development and building the system. Unlike most commercial solutions that looks ugly and boring, this beast looks great. It's a piece of art. For more details, visit BIZON website. You can place the order online and customize the system. Check the link in the description below. Thumbs up if you like this video and subscribe to our channel. See you on the next one.